In this question, you're asked to convert some prefix units, such as millimeters, to whole units, such as meters, or megaliters into liters, or kilograms into grams. And really, this is done for convenience. So let me give you an example. In countries that use the metric system, they will measure the distance between two places in kilometers or kilometers. So, for example, if something is 10 kilometers apart, 10 is a reasonable number for the distance between, say, one city and another, Albany and Troy, for example. However, you wouldn't want to measure the distance between two cities in millimeters. As another example, if you think about the transistors on a microprocessor, the distance between the two transistors may be measured in nanometers because there's an incredibly small distance between them. You wouldn't want to measure that in kilometers, the same thing you did to measure the distance between Albany and Troy. So these prefixes are used mostly out of convenience. In this case, you may have learned how to convert from one unit to another by using a decimal place, and that works perfectly fine. But here, what I'm going to show you is to use dimensional analysis in order to do these problems. Now, I'm only going to do the first two, but I want to show you how to do both of them by dimensional analysis so that you are aware of this process. Dimensional analysis is a process that must be used to solve some chemistry problems. That being said, there are of course other ways to do it, but dimensional analysis is how it will be taught and is really, in my opinion, the most convenient way of doing it. So let's take an example here of 6,000 millimeters equals how many meters? In order to do dimensional analysis, the first thing you need is an equality between millimeters and meters. Fortunately, Alex gives you a table of different equalities to convert to the base unit. You can simply click on the appropriate button and open that up on your screen if you're not sure. But what you're going to find is that 1,000 millimeters equals 1 meter. In order to do dimensional analysis, we always need an equality. So here, starting with 6,000 millimeters times, we're going to put this equality in fraction form. Said another way, we're going to put one of these values in the numerator on top and one of these values in the denominator on the bottom. How do we decide which to put where? Well, we want millimeters to cancel out. So in order to get millimeters to cancel out, we need to put the 1,000 millimeters on the bottom. And then on top, we have to put the other one, 1 meter. Remember that 1 meter and 1,000 millimeters are equal. So we essentially have two equal quantities divided by each other. Said another way, this is mathematically equal to 1. So we're essentially multiplying a number by something mathematically equal to 1, which means you're going to get the same thing. When you do the math, you're going to take 6,000 times 1 and then divide by 1,000, and you're going to find that this is 6 meters. What's important to note is that 6,000 millimeters is the same magnitude as 6 meters. So this is a mathematically valid way to do this. Dimensional analysis, as I mentioned earlier, is often used to solve chemical equations where you can't simply move the decimal point like you could in this case. Let's do the second one as another example. We want to know how many megaliters are in 7 million liters. Again, we need an equality that relates these units. And it turns out that 1 times 10 to the 6, or 1 million liters, equals 1 megaliter. Mega means a million. So again, starting with the 7 million liters times, we're going to write this in fractional form. We always have to decide what goes on the denominator on the bottom, and we always want the unit we're trying to get rid of on the bottom. So in this case, we have liters, we're trying to get rid of it, so we want to put 1 times 10 to the 6 liters on the bottom, 1 megaliter on the top. Multiply by the top, divide by the bottom, and in this case, you're going to find that this is 7 megaliters. In both cases, the 7 million liters is exactly equal to 7 megaliters, and 6,000 millimeters is exactly equal to 6 meters. So we have not changed the quantity or the magnitude of what we have. We have simply changed the unit by multiplying by a fraction created with two equal quantities that relate to two units. In this case, 1 times 10 to the 6 liters over 1 megaliter.